High visibility clothing, sometimes shortened to high-vis or high-vis, is any clothing worn that is highly luminescent in its natural matte property or a color that is easily discernible from any background. It is most commonly worn on the torso and arm area of the body. Health and safety regulations often require the use of high visibility clothing as it is a form of personal protective equipment. Many colors of high visibility vests are available, with yellow and orange being the most common examples. Colors other than yellow or orange may not provide adequate luminescence for conformity to standards such as ISO 20471. As a form of personal protective equipment, high visibility clothing is worn to increase a person's visibility and therefore prevent accidents caused by persons not being seen. As a result, it is often worn in occupations where hazardous situations are created by moving vehicles or low lighting conditions. These occupations include railway and road workers, airport workers and emergency services. Cyclists and motorcyclists may also use high visibility clothing to increase their visibility when operating amongst motor traffic. Hunters may be required to wear designated high visibility clothing to prevent accidental shooting. Some reflective tapes used on high visibility clothing can reflect as much as 82% of the source light, causing retinal damage. It is therefore recommended that aircraft pilots, professional truck, bus drivers, and operators of heavy machinery refrain from wearing highly reflective clothing while conducting their duties. Experimental use of high visibility clothing began in 1964 on the Scottish region of British Railways. Fluorescent orange jackets, known as fireflies, were issued to track workers on the Pollock Shields to Eglinton Street electrified section in Glasgow. They were later tried in other areas, such as Edinburgh, Aberdeen and Inverness. Train drivers operating in these areas were asked their opinion as to the effectiveness of the jackets. Following trials, high visibility clothing was issued to engineering and other staff working on the electrified lines of the London Midland region of British Railways in 1965. It was thought to be more important due to the higher speeds of the newly electrified West Coast main line route from London Euston to Birmingham, Manchester and Liverpool. The first version was worn as a jerkin and was visible at half a mile in normal weather conditions. Since then, features of high visibility clothing such as the EN 510 Quick Release Standard and the EN 471 and its successor EN ISO 20471 is to 2013 high visibility standards, have improved the effectiveness and contributed to improved safety for rail workers and other staff. The specifications for Rail Industry Standard RIAS 3279, TOM high visibility clothing suitable for use on railways in the United Kingdom are published by the Rail Safety and Standards Board. The Hurt report found that very few motorcyclists involved in collisions wore high visibility clothing, and that just over half of the collisions studied, nearly two-thirds of those involving another vehicle, were due to the motorist unintentionally violating the motorcyclist's right-of-way. Quote, "This dominant culpability of the driver of the other vehicle emphasizes the special need for high contrast conspicuity for the motorcycle and rider." A New Zealand case control study found that the population attributable risks were 33% for wearing no reflective or fluorescent clothing. One-third of motorbike accidents might have been prevented by wearing high visibility clothing. Traffic risks to the cyclist are similar to those faced by motorcyclists, with the main differences being that bicycling speeds are typically lower, and the bicyclist wears less protective gear. In a 2009 study, most UK cyclists and almost all motorists believed that high visibility clothing would increase cyclists' visibility. Almost all drivers agreed that cyclists need to wear reflective clothing in low lighting environments, whereas less than three-quarters of cyclists agreed, and less than half claimed that they always did so. A Cochrane systematic review of research evidence for the effectiveness of visibility aids was carried out by Kwan and Mapstone in 2006. The authors found 42 studies which collectively suggested that fluorescent clothing could increase the distance at which drivers could detect and then recognize cyclists in daylight conditions. The same review found evidence that retroreflective materials worn by cyclists at night had a similar effect on driver perceptions. At that time, there were no studies published that had actually demonstrated a reduction in collision crashes for bicyclists wearing fluorescent or retroreflective clothing whilst on public roads. A 2009 Australian study of drivers trying to see stationary cyclists on a closed circuit found that fluorescent vests were not a significant improvement on black clothing at night and that